Thank you, Steve. Certainly, fixed devices represent an exciting new marketplace that'll develop in TV white spaces, but there's also a very large marketplace that's going to develop with mobile devices. So let's talk a little bit about what those mobile devices entail and how they're going to work using the TV white space channels. So if you think about mobile devices today that use Wi-Fi spectrum, either in 2.4 gigahertz or 5 gigahertz, that'll give you a good idea of kind of the marketplace we're expecting in TV white spaces. We're going to expect to see all kinds of mobile devices, from laptops to tablets, to cell phones, to access points, gaming devices, televisions, printers, you name it. And the best way to think about white spaces for low power devices is really it's Wi-Fi and steroids. Everything you get with Wi-Fi today, you're going to get with TV white spaces, but in sort of a bigger and better fashion. So when you kind of compare what we can do today in Wi-Fi and 2.4 gigahertz and what we'll be able to do in the future with TV white spaces, what you find is that TV white spaces offers a improvement of 2 to 3x in terms of range versus what you can get in Wi-Fi. One of the challenges Wi-Fi has today is providing sort of whole home coverage. Wi-Fi does well for obviously for rooms, smaller apartments, houses, but for larger ones it can be problematic and you may need a repeater in order to get whole house coverage. White spaces will take care of that. You'll have full coverage of a house, even outside into a patio or backyard kind of area. As you can see from the bottom picture on the slide, sort of the cell sizes you can do with TV white spaces will be significantly bigger than Wi-Fi. That'll help when you're trying to cover a house, or if you're building a network to cover sort of a campus area or even an entire municipality or city. The frequencies that mobile devices can use are a little bit different than fixed devices. The mobile devices or portable devices are limited to the UHF band, channel 21 through 51. This is actually a good thing because trying to use VHF frequencies on a portable device is fairly impractical just due to the large antennas you'd have to carry around. So the FCC has said you can only operate between 21 through 51. There are a few channels, basically 37, which is reserved for medical telemetry, and 36 and 38, which in most parts of the country will be reserved for wireless microphones. But other than that, any other channel is fair game. The FCC has classified two kinds of channels. There are the non-adjacent channels, so where, let's say you're on channel 25, and both 24 and 26 are unoccupied. That is considered a non-adjacent channel. In that case, your power output is 100 milliwatts EIRP. If either 24 or 26 is occupied, then channel 25 is considered an adjacent channel. In that case, power output is reduced to 40 milliwatts EIRP. But in either case, due to the excellent propagation characteristics of the 500 to 700 megahertz bands here, you'll get very, very good coverage of area. One of the other important things is sensing is no longer a requirement. So basically the database only operation will simplify life for equipment manufacturers as they produce low power portable devices. The low power portable devices, as mentioned earlier, really comes in two different flavors. There is what is known as a Mode 2 and a Mode 1 device. I'll cover Mode 2 first. So Mode 2 device is a device that has built-in geolocation capability, and it can access the database and get a list of available channels. The geolocation capability needs to be accurate to within 50 meters, and your location must be rechecked whenever the device is powered on or every 60 seconds while it's in active operation. The Mode 2 device does its geolocation, gets its list of channels from the database, and then it can decide what channel or channels it wants to operate on. Once it's done that, it can initiate and operate a network of either fixed or portable devices. The other characteristic of a Mode 2 device is it can provide a list of channels to a Mode 1 device. The Mode 1 devices are considered portable devices that don't have any geolocation capability and can't access the database. So the Mode 1 device is dependent upon talking to a Mode 2 or a fixed device in order to obtain a list of channels. So the Mode 1 device by itself, if you just turned it on, it cannot initiate a network of either portable or fixed devices, and it can't provide a list of channels to any other devices. A Mode 1 device is always dependent upon a Mode 2 or fixed device. So to kind of give you an illustration of how this would work, the first scenario here is one of a typical access point. If you're familiar with Wi-Fi, this looks very much like a Wi-Fi scenario. You'll have an access point. It's considered a Mode 2 device. It'll geolocate itself, and then it'll talk to the database and get a list of available channels and decide which channels it wants to operate on. Once it's decided that, it'll start broadcasting an SSID, and then client devices can then connect to that SSID and utilize those same channels. Again, very similar to how Wi-Fi operates today, so shouldn't be anything confusing here. Now, the interesting thing is that access points are not the only thing that can be Mode 2 devices. So in the next scenario, we've removed the access point, but we've taken the laptop and said you're going to be a Mode 2 device. So if the laptop has geolocation capability in it, and many laptops today do, it can then talk to the database, get a list of channels, and decide what frequencies it wants to operate on. And then basically it turns on and broadcasts an SSID, and then it can connect to other Mode 1 devices. So this is technology that actually exists today. If you're familiar with Wi-Fi, there's a new feature of Wi-Fi known as Wi-Fi Direct, where a laptop or even a cell phone can actually become a sort of master device for a Wi-Fi network, and that's known as Wi-Fi Direct. So the same sort of feature can be applied in TV white spaces and give you the same sort of client network connected to a master device. So the good news is these sorts of scenarios that I just talked about are well on their way to becoming reality. The IEEE, which is sort of the keeper of the 802.11 Wi-Fi standard, has already formed a task group back in January of this year around TV white spaces. The formal name of the task force is 802.11 AF, and as you can see, their objective in this task force is to modify both the physical layer as well as the MAC layer of Wi-Fi to be able to work in TV white spaces and meet all of the FCC requirements there. And they're going to modify Wi-Fi from its current 20 megahertz channelization to be able to use 5, 10, and 20 megahertz channels. So the good news is, as I said, this task group was formed earlier in the year. They've already been hard at work, and they're making good progress. And if you want to see the details of what they're doing and how they're progressing, I encourage you to go out to the IEEE site that I've linked in the slide to be able to get more details. So an exciting future for mobile devices in TV white spaces. Expect in the future to be able to see devices that operate in 2.4, 5 gigahertz, as well as TV white spaces.